if 13 moles of N2 are reacted with 8 moles of O2, how many moles of ammonia can be made? And ammonia, not ammonium, ammonia is NH3. Okie dokie. So I have a question here, and I have been given not one reactant, but I have been given 2 reactants. And if I am given 2 reactants, then I know that this is a limiting reactant problem. And if it is a limiting reactant problem, my first step is always going to be find the limiting reactant. Okay. So let's see. In order to find the limiting reactant, I thought that this started at 2. Oh, the office hours start at 2. That's okay. I've recorded the whole thing. You can totally just, watch what you missed up till this point. Okay. And you're just joining us for this question. It's all good. Don't worry. There will be glitches like this in these first days as we figure out what the schedule is and I figure out how to post it so everybody knows and all of those good things. Okay, so we're going to start by finding the limiting reactant, and anytime you're finding the limiting reactant, what do you need before you can do the question? Starts with a B. We need a balanced reaction. Whoops. Okay, balanced equation. Yes. Okay, so who are my reactants? Oh, this should not say O2. That should say H2. Otherwise, I don't know how you're going to get an NH3 out of N and O. That would be really weird. Okay, there we go. That's better. Okay, so we have reactant A is N2, reactant B is H2, and our product is ammonia, which is NH3. To balance that, I'm going to put a 2 here, I'm going to put a 3 here, and that should do it. Okay, so to find the limiting reactant, you find step 1, find the what would go in those blanks? Blank number 1, blank number 2, blank number 3, blank number 4. Nobody? Yeah, we're going to find the moles of product that could be formed from, yes, we could do reactant A. I'm going to say from each reactant because that way I don't have to write out, then find the moles of product that could be produced from reactant B. So each reactant, and here we have 2 reactants, so this is going to be 2 calculations. Okay, whew. So reactant A is our N2. So we want to find the moles of product, NH3, that we could find from reactant A, which is the N2. Well, how much N2 are we starting with? We are starting with 13 moles of N2. So we are starting with 13 moles N2. And we want to find moles of NH3. So do we have to do anything before we convert to moles of NH3, or can we just go straight there? Can I convert? Can I do this conversion? Is that okay? Absolutely. So we've just kind of saved ourselves a step, right? In the past questions, I've given you grams. Some of the ones on the homework and stuff had liters. Here, you're just starting from moles, so it's even easier, but we still need that ratio from the equation. So we have a 1 in front of the N2, and we have a 2 in front of the NH3. So 13 times 2 is 26 moles of NH3. And that's from the N2. All right, second thing, we need to find our other product. Not our other product from our other reactant, so that we're going to find the moles of product from our other reactant. And our other reactant is H2. And what do we know about H2? We know that we have 8 moles. So we have 8 moles of H2. And our reaction, we have 3 moles of H2 for every 2 moles of NH3. And it's looking like this is going to be my limiting reactant. I can just tell that right away because 2/3 of 8 is certainly smaller than 26. But I'll do it just for form's sake. We get 5.33 moles of NH3. So the question said, how many moles of ammonia could be made? Well, out of those 2, it is going to be that one right there. Okay. I could also ask you how many moles of NH3 are in X. By how many moles? Is the NH3 in excess? That's kind of phrased weird. It means the same as how many moles of NH3 or not NH3, N2. By how many moles is the N2 in excess? Another way of saying that maybe is a little more straightforward is how many moles of N2 are left over. Okay. And so we could say, all right, we did it with mass before, but it's the same principle if you have moles. The moles of N2 left over is going to be the moles of N2 at the start minus the moles of N2 used. Okay, and that's going to be, let's see, the moles of N2 at the start, we know that, we were given that, it was 13. 13 moles of N2. In order to find the amount used, this is the amount used to react with the limiting reactant, which in this case is the H2, and so we have to calculate it. So moles of N2 used to react with limiting reactant, H2. Okay, so we would have, we're starting with the H2, which we had 8 moles of H2, and we want to find the moles of N2. Cancel moles of H2. The coefficient of N2 was 1, and the moles of, and the coefficient of H2 was 3. So we get 8 divided by 3 is 2.6, repeating. So I'll just write 667 for now. Way more digits than I need. Okay. Moles of N2 used. So that's our moles of N2 used. So we're going to put that in here, and minus 2.667 moles of N2, and we get 10.3. This example doesn't do much good for sig figs, I guess. We would have to say, if I have my 13 here, that's my uncertain digit. And down here, oh, I've only got one uncertain digit. So that would just be there. So I would have to round that then to 10 moles of N2 are left over. And there we are.